Hello friends, today I am going to solve a GeeksforGeeks problem of 19 June, and the problem stated we have given a sorted array, and for each index we need to make all elements of the array from index 0 to I equal using the minimum number of the operation, and for each index we need to find the minimum number of the operation required to make the prefix array equal. Okay, and at the last we need to return the resultant array for that represent the operation record for each index to make the elements equal. Okay, so let's understand by an example. So currently I am at index 0, and to make this prefix array from 0 to 0 equal, how many number of the operation I record? That is 0, because there is only one element. And from 0 to here at index 1, how many number of the operation I record? I can either increase or decrease. So to make these two values equal, what I can do? I can either convert 1 as 2 or 2 as 1. So I can either increase 1, so the value becomes 2. And 2 is already 2, so the number of the operation record 0. So here for the number of the operation record 1. Okay. So I move ahead, and to make this prefix array equal, how many number of the operation I required? So to first we need to consider that to make a prefix array from 0 to ith index, how can we make all elements equal with the minimum number of the operation? We first intuition we need to find out this one. So for any prefix array from 0 to ith index, we need to find its median value. And how can we find the median value? As the given array is sorted well, so our median is lies between some around mid. So for an prefix array 0 to I element, how can I find the median? 0 plus I by 2, that is I by 2. Okay, so this is how I can find the median value. And after finding the median value, we need to find out the operation required to make all the elements equal. So how can I find this? By finding the absolute difference between the element and the median value. Okay, so let's take a bigger example. Let's say here, to make these all element equal with the minimum number of the operations. So how can I find the, so first I need to find the median value. So my current index is at 6. So my median value is something like around 3 here. So if my median value is 7, so minimum number of the operation required to make all elements equal to 7. So to make 1 equal to 7, so I need to convert it. So minimum number of the operation required 6. For this, minimum number of the operation required 5. For this, minimum number of the operation required 4. For this, minimum number of the operation required 0, because 7 is already a median value. For this value 0, and for this value is 3. So total summation, total number of the operation required 6, 4, 10, 5, 15, 3, 18. So for this array, so to make this prefix array equal to, where every element are equal to each other, I need the minimum number of the operation required 18. Okay, so this is how I find. But we need to consider for any prefix array from 0 to ith index. What I need to check? I need to compare all the previous value from 0 to ith with the median value. So this can take O of n time complexity, and we are already finding the operation for each index. So this can take O of n equal. So we need to optimize it. So how can I optimize it? By using something around using prefix summation. So yes, we can do it. So let's find the prefix summation. So for this index, the prefix sum is 1. For this index, the prefix sum is 3. For this index, 3 plus 3 6. For 6 plus 7, that is 13. 13 plus 7, 20. 20 plus 10, 30. And 30 plus 19, 49. So I assume that you know how to find the prefix summation. So how can we find it? We can find it from traversing the whole array 0 to n, and for each index we can find it by, for each index I can find the prefix summation of I via prefix summation of I minus 1 plus array of I. This is how we find the prefix summation, okay, for an array. And prefix of 0 is always array of 0. Okay, so we find the prefix summation. Okay, yes, we find it. And let's take this. Let's suppose we again need to find the number of the operation required to make all elements equal to 7 for this prefix array. So our median is lying something around this index, that is 3. So first thing I need to notice that before this index, as our array is sorted, the value lies between it is always less than or equal to the median value, and the left side value, this one, is always greater than or equal to my mid value, okay, median value. So to find the number of the operation, how can I find it? So I find it generally by finding this that difference between the element and the median value. So I find something around this one that represent the absolute value. So let's say for the 7, before using the prefix array, I something find around 7 minus 1, 7 minus 2, 7 minus 3. This is how I can find it. But as now I can consider that for the left elements, how many times I need to subtract the median value. That is median index plus 1. So yes, so I will find median value into how many times, that is median index, let's say mi plus 1. Okay, so for this the value becomes 7 into my current index is 3, so this becomes 4, so the value becomes 28 for this case. Okay, and what I need to do, I am subtracting each element from this to my median value. So something I find that I am subtracting something 7 minus 1, then I am adding 7 minus 2, then I am doing 7 minus 3. Can I say that this represents 7 plus 7 plus 7 and minus 1 plus 2 plus 3? Can I say this one? Yes, we can say this one. So here what I will do, I will subtract my prefix sum of median index. This is how we find the minimum number of the operation required to convert the element of the right one to equal to median value. So currently it is 28 minus my prefix summation of median index, that is this one, and this one is 13. So let's subtract 13. So the value becomes 8 minus 3, 5 to 15. Let's check. To make this element, we record the 15. Okay. So let's erase this one. Let also erase this one. So we find the summation for the left number of the operation required to make all the left elements equal to median value, that is 15. You can also add this one, you can find it. Okay. And for the right index from this to this index to this, how many number of the operation I require? So can I find something around what I am doing here? First, I need to notice this one. So I am doing here 7, because this element is always greater than or equal to 7, my median value. So I will do 7 minus 7 plus 10 minus 7. So can I say that this represents 7 plus 10 minus 7 plus 7. Okay. So how can I find it? This one. So I can find it by prefix of my current I element minus prefix of my median index. This is how we can find it. This one. And what I am doing, I am doing median value, that is, let's say mv minus, sorry, into how many times. So how can I find the how many times it is? So our current index is I, and minus median index, I minus median index. This is how we can find it. Okay, so let's check for the right one. My current prefix psi for this one is 30, and my prefix minus median one, that is 13. So the value becomes 13, 30 minus 13, 30 minus 13, that is 17. Okay, and for my median value is 7. And how many times? That is my current index. My current index is at 5, and my median index at 3. So 5 minus 3, that becomes 2. So 17 minus 14, that becomes 3. So our left operation we got 15, and our right operation we got 3. The total number of the operation we got 18. So we can find that our total number of the operation is 18, and that is also represent without brute force approach. That is also representing 18. Okay, so this is how we can find it. So let's go into the code panel. Let's erase it and let's code with you. So I will find the size of the array. So what I need to find? I need to find the prefix sum. So here I will consider long prefix sum, and here I will take of size n with value 0, and here I will do prefix sum of 0 assign with array of 0, and for each index from 1 to n I will assign the prefix of I is equal to prefix of I minus 1 plus array of I. So I find the prefix sum, and I need to find the number of the operation for each index. So we need to traverse the whole array again. And so first I need to find the median index. We can find it by this one, I by 2. And the median value I can find it by array of median index. Okay, so how can I find the prefix sum, means number of the operation, by looking for the left operation required. So left operation, how can I find this? So let me go into, this is our formula for to find for the left one. Let me erase all this one. So this is formula for to find the left number of the operation. So this is a median value into, this is a median index plus 1. So median index plus 1 minus prefix of median index. Yeah, and the right operation required is, we can find the right operation by using this formula. So prefix sum of I minus prefix sum of index. Prefix sum of I minus prefix of median index, this one, and minus median value into I minus median index. Yeah. And for each index, we need to store it. So I will consider vector of end response of size n. And for each response of pi, what I will do, I will add it both operation, left operation plus right operation. At the last, I need to return response or resultant array. So let's compile and run. So yeah, solution is working fine. Let's submit it. So yes, our code is successfully submitted. So let me update this solution here for the 19 problem, 19 June problem. So let me edit this one. Hmm, let me publish it. So yeah, I have updated the code solution here. You can check it out and find it today. And so thank you for guys. Really like and subscribe. It motivates me a lot. Thank you guys.